What happens when the universe hits the delete button? Black holes are the ultimate cosmic enigmas, regions so dense that not even light can escape. But are they just nature's trash compactors, crushing everything into oblivion? Or could they be hiding something more exotic? Like secret gateways, wormholes, to other dimensions, or even other universes? Buckle up, because today, we're diving headfirst into the darkest corners of the cosmos. The concept of black holes was born out of Einstein's general theory of relativity. While Einstein himself doubted their physical reality, later physicists took the math seriously. In 1916, Karl Schwarzschild found a solution to Einstein's equations that described a singularity, an infinitely dense point, surrounded by an event horizon, the boundary beyond which nothing returns. Fast forward to today, and black holes are no longer theoretical. We've detected them through X-rays from infalling matter, through gravitational waves when two black holes collide, and most recently, we even photographed one, the iconic image of M87 supermassive black hole in 2019. But for all we've learned, one mystery remains: what exactly happens inside a black hole? And could it lead somewhere else? Are black holes the end of everything, or could they be passageways to something radically different? A black hole is defined by its event horizon, the point of no return. Once something crosses this threshold, it can never escape. Inside, gravity becomes infinite, or so our equations suggest. At the very center lies the singularity, where all known laws of physics break down. Surrounding the event horizon is often a fiery disk of matter called an accretion disk. It heats up due to friction and gravitational forces, emitting intense X-rays and sometimes launching relativistic jets that can stretch for light years. So far, this all seems like destruction. But is that all there is? Does this idea of a point where physics collapses freak you out, or fascinate you? Let's talk in the comments. Here's a big problem in physics: the black hole information paradox. According to quantum mechanics, information about particles, like their exact state, should never be destroyed. But black holes seem to erase all that information once it crosses the event horizon. Stephen Hawking initially suggested that information is lost forever, which led to a clash between quantum mechanics and general relativity. Later theories, including Hawking radiation, imply that black holes slowly evaporate, potentially leaking information back into the universe. But how this happens is still hotly debated. Some think the information gets scrambled and encoded in the Hawking radiation. Others suggest that the event horizon acts like a hologram, storing everything that falls in. Do you think information can be truly lost? Or is the universe just really good at hiding it? Back in 1935, Einstein and physicist Nathan Rosen proposed that black holes could be connected to white holes, regions where matter emerges rather than falls in, forming a tunnel through spacetime, a wormhole. Wormholes are fascinating because they might allow travel between distant regions of the universe, or even between different universes altogether. The catch? They appear to be inherently unstable. Without some form of exotic matter with negative energy density, they would collapse the moment anything tries to pass through. But string theory, quantum gravity, and newer models involving ER equals EPR, a bold hypothesis by physicist Juan Meldacena, suggest deep connections between wormholes and quantum entanglement. If true, black holes might be more than just death traps, they might be bridges. Would you dare step into a wormhole, not knowing where, or when, you'd come out? If a black hole is where things fall in, a white hole is where things come out. Though purely theoretical, white holes are predicted by general relativity as time-reversed black holes. Nothing can enter them, and matter is ejected outward. Sound familiar? Some physicists wonder, could the Big Bang itself have been the exit wound of a white hole? There are even ideas that when matter hits the singularity of a black hole, it doesn't get destroyed, it tunnels through a white hole and reappears somewhere else. If that's the case, then black holes aren't endpoints, they're cosmic portals. Could we have been born out of a white hole? Or are we inside a black hole right now? Some theorists have suggested something even more radical, that black holes themselves may be tied to the fundamental computation of the universe. Physicist Seth Lloyd proposed that the universe is a quantum computer, and black holes are the ultimate data processors. They compress, encode, and perhaps even recycle information in ways that hint at computational processes. Add this to theories like the holographic principle, which states that all the 3D information in a region of space can be encoded on a 2D surface, and you start to wonder, are black holes part of the operating system of the cosmos? If black holes are computers, who, or what, wrote the code? One of the wildest ideas out there is that every black hole might birth a new universe on the other side. This concept, known as cosmological natural selection, suggests that black holes might act like seeds, each forming a baby universe inside. That universe could have slightly different physical constants, potentially favoring the formation of more black holes. If true, then black holes aren't just the ends of things, they're part of a larger evolutionary process, and our own universe could be the result of such a parent universe. What if falling into a black hole just means waking up in a completely new cosmos? Here's something surprising, black holes might be the architects of galaxies. At the heart of nearly every large galaxy, including our Milky Way, lies a supermassive black hole, millions or even billions of times the mass of our Sun. These titans are not just lurking in the shadows, they actively shape their environments. Through powerful gravitational forces and high-energy jets, black holes regulate star formation by heating and ejecting gas from the galactic core. This process, known as AGN feedback, prevents galaxies from growing too fast or becoming too chaotic. In a strange twist, these destroyers of matter may actually be necessary for building and stabilizing the cosmos on a grand scale. Some theories even suggest that galaxies couldn't form at all without the early seeds of black holes, meaning, in a way, we might owe our existence to them. Could the black hole at the center of the Milky Way be the reason we're here at all? What are your thoughts? It might sound like science fiction, but scientists have actually proposed harvesting energy from black holes. The idea comes from the Penrose process and the Blandford's-Najek mechanism, ways to extract rotational or magnetic energy from spinning black holes. In theory, an advanced civilization could build a massive structure, like a Dyson sphere, around a black hole's accretion disk to collect its immense radiation output. This could generate energy at scales trillions of times beyond anything humanity can currently produce. Black holes, then, aren't just dangerous, they could be the ultimate power plants. If we survive long enough, we might one day orbit these beasts not in fear, but in awe and utility. Would you live near a black hole if it meant unlimited energy? Or is that just asking for trouble? So, are black holes just the universe's garbage disposals, or are they something far stranger? From paradoxes in physics to wormholes, from possible multiverse portals to cosmic rebirth, black holes might hold the secrets to understanding everything. They're not just death, they're potential gateways, engines, and maybe even storytellers of the cosmos. Now, we want to hear from you. Do you think black holes destroy, transport, or transform reality? Drop a comment, hit like if your mind is spinning, and don't forget to subscribe for more cosmic deep dives. Until next time, stay curious.